Quadratics, written and presented by me, Jean Leguay. Here's the legal stuff. Firstly, why quadratic? Quad makes you think of four things, like a quad gun or maybe a quad bike. But in fact, what you should be thinking of is quad as in a square. Quad means square. And the quadratic equation, this is the standard form of the quadratic equation, y equals ax squared plus bx plus c, has got a square in it. The highest power of x is a square. So it's called a quadratic equation. Now, when your a value, a is the value that's multiplying the x squared, when that's a positive, then the graph for a quadratic goes down and comes back up. This shape, by the way, is what we call a parabola, and it's very useful. We find it all over the place. If, on the other hand, we have a negative a value, then the graph goes up and comes back down. Other things about this graph. At the y-axis, which is where x equals 0, then if you just put x equals 0 into the quadratic equation, then the first term cancels out, becomes 0, the second term becomes 0, and we're just left with a c value. So where it crosses the y-axis is simply the value c. Where it crosses the x-axis, where it's got no height, where y equals 0, now that is what we call the roots of the equation. So they're the x values where it crosses, they're the roots of that quadratic. This one has got two roots, two places where it crosses the axis. Here's another one that's got two roots. This one has got one root, and this one never crosses the x-axis, so we say it has no roots. The point at which it turns around is given by the equation minus b over 2a. Don't worry about where that's come from, just take it as read that the turnaround point is minus b over 2a. To give an example, here's an equation. Y equals 0.5 x squared minus 4.5 x minus 2.5. So the a value is 0.5, the b value is minus 4.5, and the c value is minus 2.5. It turns at minus b over 2a. So putting that in, minus 4.5 divided by 2 times 0.5, which was the a. And that comes out as 4.5, and that looks about right. None of this would have been interesting to anybody apart from mathematicians if it wasn't for ballistics. Ballistics is all about the firing of guns. Ballistic trajectory just happens to follow this equation. Y equals minus 0.5 gt squared plus VOT plus y0. Looks horrible, but it's not too bad. The g, that's just gravity, because when you fire up in the air it tends to fall back down. The VO, that's the velocity, initial velocity given to it by the gun. And the y0 is the height that you're firing the gun from. Maybe you're standing on a hill or something. So let's fire this gun. I'll get a better angle, and boink, there it goes. And that follows a lovely parabola, which we should expect because it's a quadratic equation. It's got a squared in it. By working out this quadratic equation, you see, you can tell exactly how long the cannonball is in the air. And if you know exactly how long the cannonball is in the air, then you know where it's going to land. This has of course got two roots. The first place where it touched the ground was where we fired it, and the second place where it touches the ground is the unfortunate thing it's going to land on. So finding the root of quadratics. There's two ways. The first way is to draw a graph. So here I've got an example equation, y equals 0.5x squared plus x minus 1. And the standard equation is next to it. Things that we know about. We know it turns at x equals minus b over 2a. So substituting in, b is 1. So substituting that, and a is 0.5, putting those values in, and we find that it turns around at minus 1, at x equals minus 1. I'd like to find the y coordinate of that turnaround as well. So what I'll do is I'll throw that x equals minus 1 back into the equation. There's the original equation. Throw in x equals minus 1, calculate it out, and you find that y equals minus 1.5 at that point. So we have one of the points on this graph, which is minus 1, minus 1.5. That's the turnaround. Another thing we know, if x equals 0, then y just equals c. In our case, y equals minus 1. So we have another point. At 0, y equals minus 1. So 0 minus 1 is another point on this graph. What I then do is I choose a range of x values that will include those two values that I just found. So I'm going to go from minus 3 to 3. And I calculate each one of the terms individually. So minus 3, throwing that into 0.5x squared, I get 4.5. Throw that into 1 times x, I get minus 3. And then minus 1 is just minus 1. Add all those together, I get 0.5. Then I take minus 2, throw that into 0.5x squared, and I get 2. 1 times x, I get minus 2. And then just minus 1, add them all together. So going down, I get 0.5, minus 1, minus 1, minus 1.5. I think we know about that one. That's our turnaround. 0, 0, minus 1, and minus 1. We know about that one. That's where it crosses the axis. 0.5, 1, minus 1. And that's 0.5. 2, 2, minus 1. And that's 3. 4.5, 3, minus 1. Add them all together, 6.5. So I've got a bunch of points. Just make a bit of space. Come across. There you go. Clean that up. And start to plot. Boink, 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 boink. There we go. And draw a line. There it is. That's my graph. Easy. And this graph crosses the x-axis in two places, so it has two roots. Looking at the graph, I reckon it's about minus 2.7 and 0, and the other root is around 0.7 and 0. The other way of doing this is to use the magic formula. The magic formula just works like a sausage machine. You just put the values in, and out pops the roots. Now, you don't always get roots. Sometimes you have 2 roots, sometimes you have 1, and sometimes there are no roots. If b squared is greater than 4ac, you're going to get 2 roots. If b squared equals 4ac, you're only going to get 1 root. And if b squared is less than 4ac, there won't be any roots. So before you do anything, check to see that you're actually going to get some roots. Don't worry about where the magic formula came from. It's just a sausage machine. You just plumb the numbers in and out comes the answers. Let's do an example. Here's the one I did by graph earlier. Y equals 0.5x squared plus x minus 1. There's the magic formula. In this case, a equals 0.5, b equals 1, and c equals minus 1. Throw them into the magic formula. Calculate it out. 1 squared is 1, minus 4 times 0.5 times minus 1. That all ends up as plus 2. So I end up with minus 1 plus or minus square root of 1 plus 2 all over 1. All over 1, that will just go away. And I just end up with minus 1 plus or minus square root of 3. Now, there are two answers, plus or minus. So I'll do the plus first. So the square root of 3 is 1.7321, and I've got minus 1 plus 1.7321, and the answer is 0.7321. Now I'll do the minus. Minus 1 plus or minus this time, square root of 3, which is 1.7321, minus 1 minus that gives me minus 2.7321. So there are the 2 points where it crosses the axis. There are the 2 roots. Looking at the graph, now when I just graphed this I found it as minus 2.7 and 0.7, but using the equation I get much more accuracy, and I find the first root is minus 2.7321 and the second is 0.7321. And that's quadratics, and that's finding 2 ways of finding the roots. You graph or you use the magic formula.